In this question, we've been asked to get the general solution of this trig equation over here. So the first thing I see is a 90 minus. So the alarm bells are ringing for cofunctions. So I'm going to grab the list of cofunctions and let's see what we can do with it. Okay, so I see cos of 90 minus an angle. So I want to find that here, cos of 90 minus the angle will change into sine of that angle over there. So the right hand side, I'm just going to change it to sine of 2 theta. And after I made that change, the alarm bells are ringing again. 2 theta, I see a double angle. 2 times something, another way of saying that is doubling it. So let's grab our double angles. And then luckily with sine of 2 theta, there's only one double angle for it. So I'm going to use this bottom one here. And I'm going to expand sine of 2 theta into 2 sine theta cos theta. And after I've done that, this becomes a quadratic trig equation because I see a sine squared over there. So with quadratic equations, you want to move everything to one side and make it equal to 0. So what I'm going to do is move this term over to that side so it equals 0. And when I do that, it will become the minus version of itself. So it will change to minus 2 sine theta cos theta. And why I want to do that is so that I can set myself up to factorize. So now I'm going to factorize out the highest common factor. And I'm going to kind of over-explain this so that you can see it a bit better. Sine squared theta is just a shorter way of writing sine theta times sine theta. Like this. And now we can recognize the common factor a lot easier. They both have a sine theta, this term as well as this term. And they both are divisible by 2. So my HCF is 2 sine theta. And you want to kind of be able to recognize that with this just being the 4 sine squared. So I'm going to change that back quickly. And now we're going to remove the 2 sine theta as a common factor. So I start off by writing the 2 sine theta and I open a bracket. 4 divided by 2 will leave me with another 2 here. Another good way to think about it is 2 times 2 will give me 4. I removed one of the sines here as discussed earlier, so there's 1 sine theta left over. And then that sorts out the first term. Now the minus will stay in between them because my common factor is positive, so I'm going to keep the minus there. And from the second term, I removed the 2 sine theta as a common factor, so all I have left over is this cos theta. And now we have successfully factorized that into this. Now, as per quadratics, we grab each factor and work with them separately after we make them equal to 0. So this is factor 1 and this is factor 2. So I'll start off by saying factor 1 equals 0 underneath. Just like that. And then I'll put the word or in between them. And then I grab factor 2 and make factor 2 equal 0. And after I've split up my factors like that, I'm going to start working on them separately. So let's start off with this guy over here. I want to divide both sides by 2 to get rid of this 2. And when I do that, these 2's cancel, just leaving with sine theta. 0 divided by 2 is just 0. So essentially the 2 just disappears. Now there's one of 2 ways we can go from here. We can think of the graphs, use the graphs, or we can go down the rabbit hole with the reference angle, quadrant, and solutions. So I'm going to do the reference angle, quadrants, and solutions just to strengthen my general solution skills. So I'll start off by getting my reference angle. I take the sine over and it becomes arc sine or shift sine. So my reference angle is shift sine of 0. And I'm simply going to lean on the calculator to help me work that out. Shift sine of 0 will give me 0. So that's my reference angle, 0 degrees. And now I've got to select the quadrants that I'm going to be working in. So I do a small little cast diagram somewhere to help me select them. And then once I've got my little cast diagram in, I look at this line, sine of theta equals 0. So you can choose either both the positive quadrants for sine or both the negative quadrants. I find it easier to work with the positive quadrants. So I'm going to go ahead and select quadrant 1 and 2. And now I'm going to get my general solution for quadrant 1. So for quadrant 1, it's going to be this angle theta always goes on the left-hand side of the equal sign. So I'm going to say theta equals. And then for quadrant 1, you just put your reference angle in, and then we're going to say plus K360 because we're working with sine. And I cannot simplify that any further, so now I'm done with quadrant 1. Now I'm going to focus on quadrant 2 over here. And quadrant 2 is the 180 minus quadrant. So I'll start off the same before. This angle here goes on the left. And I'll say theta equals 180 minus my reference angle of 0. And 180 minus 0 is just 180. And then next to that, I do have to put the plus K360. Remember, sine and cos is 360, whereas tan is 180. So let's just copy paste the plus K360 next to that. And then just to finish these general solutions off, I need to state that k is an element of integers. And how we do that in mathematics is we say KEZ like this. So it's just a normal K with this weird looking E and the Z with like a double stroke over there. And I need to do it for both the general solutions. And now I've officially wrapped up the general solutions for this factor over here. So now I'm going to kind of do the same process with my second factor, but there is a bit of a trap in the beginning. Okay, so over here, what we want to do is take this cos over so that we can divide both sides by cos to get a tan. So let me show you how we accomplish that. So if we move this negative cos over, it becomes positive cos, just like that. And then we divide both sides by cos theta. And the reason why we do that is so that we can use the trigonometric identity of sine over cos is tan. And remember, you've got to know that off by heart. Okay, so this will change into 2 tan theta. Causes here cancel and just leave you 1. And now I want to get tan theta on its own. So I'm going to divide both sides by 2. So tan theta will equal 1 over 2, formerly known as a half. And after we've done that, we're going to start our process of reference angle, quadrants, and general solutions. We call that the QRS method: quadrants, reference angle, and solutions. And the beautiful thing about tan is you don't need to do both quadrants. You can just do one quadrant. So let's get a little cast diagram going. And now I look at this line and I can see tan is positive. So tan is positive in this quadrant and this quadrant. And remember, as discussed earlier, we only need to do one of these quadrants. I'm going to do this one because it's easier. So I don't even need to do this one. And we're going to start off by getting our reference angle. So if we take that tan over, it's going to be shift tan of a half. Okay, and if you know your trig functions well enough, you'll know that that's 45. But let's just check it really quickly. So shift tan of a half. It is called arctan, but I like saying shift tan so that you remember what to type in your calculator. And that gives me 26,57. And now I just need to do the general solution in quadrant 1. So quadrant 1 will just be this equals, or theta equals in this case. And in quadrant 1, I just put my reference angle, and then I'm going to say plus K180 next to that because I'm working with tan. And after I've got that down, I've just got to slap on the k as an element of integers next to that general solution. And then I'm officially done with this behemoth of a trig solution. Okay, and last but not least, let's look where these 16,000 marks come from. First mark will come from using your cofunctions to turn cos of 90 minus 2 theta into sine 2 theta. Second mark comes from the expansion of this through the use of double angles. The third mark comes from the correct factors. The fourth mark comes from making each factor equal to 0. Fifth mark comes from these two general solutions, and the last mark comes from this general solution that we got through the tan.